right? If I implement the runnable interface, what I have to do? I have to provide a logic for or provide a body for run method. I have to override a run method. Then I have to create an object for subclass. I have to create object for subclass. That object I have to pass to thread class. That object I have to pass to thread class. Let's see. I have a class A which is extended. Already it's extended class B. Let's assume that it's already extended class B. If I want to make my class A threadable, what I have to do? I cannot extend because I already have used extends once. I cannot go ahead to say comma and threads. I cannot say this. Why? Because it is not allowed in Java. So what I can do? I have to implement runnable interface. Runnable interface. So if I implement runnable interface, I have to override public void run method. I have to override public void run method. Then what I have to do in main class, in main method, I have to create an object for A. I mean the class which I'm going to implement for threadable. That object has to pass through a thread class. Thread T1 equal to new thread of A. Else I cannot create any threads. This is the procedure to, if you go for implements, this is the procedure. If you go for thread extending thread, that's pretty simple. Class A extends thread class. Here also you have to override the run method because our logic will go, our whichever the code you want to execute separate thread, that logic has to go inside the run method only, else it will run on the main thread. If you want to run any logic, if you want to execute any logic in with a separate threads, we have to put that logic into run method only. Run, here will keep your logic. In main method, you directly create an object for the A, class A, new A, and you start A dot start. A dot start will directly do this. We don't need to create object and we don't need to pass through a thread because already my class is thread now. My parent class is thread. Okay, this is the difference between the creating thread in two different ways. And also please make sure that try to understand which scenario which class has to implement. Whether runnable interface I have to go through, or I have to go with the thread class. Okay, now let's see. In the last session I want to give more information on, like, let's assume that it's a question for you guys. I hope you guys have might have done background. It's a question for you. Let's assume that my class A extended threads. Let's assume that it's extended thread, and it has a run method, and it has a start method, and in main method public static void main. In the main method I created a equal to new A, and A dot start, start. When I say A dot start, which method will execute? Here, which method will execute? Which method will execute? Tell me guys. Now I said A dot start. Will it execute this method or will it execute this method? I hope we have seen it yesterday, but still I want to ask you guys how much you understood. I just want to understand. Please guys, go ahead and no, tell me whatever it is. It will execute start method. Correct. It will execute start method. Will it execute a separate? Let's assume that. And this a dot set name I have given as a thread 1. So will it the start method execute using a main thread or thread 1? There are two threads now here, which I have created one thread. This is our thread, and JVM will launch the main thread, right? Even though if you didn't extend threads, even though you didn't create any threads in your program, the JVM will start with it will start the execution using the main thread. The thread name is main. Our thread name, our child thread name is thread 1. Our child thread is thread 1. Now, as we said, the start method will execute. This will execute with the main thread or thread 1. It will execute with the main thread only. Why? Because even though we have extended thread class, and even though we have my class is eligible to thread, but still we are not accessing a threadable way. The threadable way is that when it says start, it has to call the run method. Internally, it has to call the run method. But I have a start method in my class. So when I say start object dot start, it will always look for the it's a local. So always start look for the local methods. It is not like the thread framework design. So they'll start executing this, and it'll start executing with the main thread only. Okay, let's assume that now I say a dot run. So when I say a dot run, ideally it will call this method. Okay, it will call this method. So my question is here: will it call with the thread child thread 1, or will it call with the main thread? The run method will execute as a separate child thread, or will it execute as a main thread only? How it will execute? I said a dot run. Now a dot run. So now will it execute by it will get executed by main thread, or it will get executed by our thread 1? Okay. No, it will execute from the main thread only. No, not from the thread 1. It will execute from the main thread only, because when you have created a thread, I'm going to explain the life cycle now. We'll see the life cycle. So then we can easily make the difference. When you want to start your thread, when you want to start your child thread, you have to use a dot start. And in this case, we should not have this method in this our thread class. We should not have. This a dot start is this is the way to call the threads. And here our thread will start. This is the method a dot start. When you call a dot start method, your newly born thread. See here, when you create a thread object, it's just born. It is just born. Still it didn't alive. It is just born. It means that still it didn't go and running. It is not running. It is just born, and it is ready to run. As soon as we call a dot start, as soon as it's called a dot start, your CPU will pick this thread and it will start executing this part. That time your thread will running. Your child thread will start running. When you call with a normal way, like normal method way, it will not execute it, or it will not call your child threads. To call a child thread, there is a special way. So we have to go with that way only. So when you create a thread, it is a newborn state. This is a life cycle. We're going to explain that. I'll explain it with a diagram and all. And when you say a dot start, your thread is ready to execute. Is ready to execute. Then your CPU will pick the thread. Then it will start executing the process. Clear, guys? Understood the difference? Or do you want me to go through one more time? Yeah, good. Now let's see a life cycle of the threads. Let's see a life cycle of the thread and what are the stages, what is the state of the threads. We will see that now. Okay, there are different states of the threads. New means newly just born. It's a born thread, newborn. Okay, runnable, running, blocked, terminated, or dead. Okay, so what is the state of newborn, and what is the state of running, and what is the state of runnable? We will see them one by one. When you create a thread using either of the way, any way, use extending the thread class or implementing the runnable interface. What we are doing in the runnable interface, we are creating a thread for the class and we are passing to thread class. Even that is also new operator, right? So when you say new, it can be a thread or it can be a new your class, demo thread demo class. Let's assume that thread demo class. When you use a new, this thread is just born. This thread is just born. We not yet invoked the start method, and t1 dot start. When you say t1 dot start, one second guys, one second. So when you say t1 dot start, it is about to run but still is not running. CPU is not picked your thread. We will see that also on what are the ways the CPU will pick. Your CPU is not yet picked your thread, but it is where it is ready to start. That is called, here only you will get the, this is new state, this is, it is ready to runnable as soon as your CPU is picked running, right? Now then what is the blocked state? When you call t1 dot sleep or wait or join, when you keep them in a waiting state, so it will move from running state to, it will go from running state to runnable state. When you call this, it will move to running state to runnable. That is called blocked. That is called blocked state. Clear guys? When it will go to blocked state, it will go to from running to runnable when you call sleep, wait, or some other IO operations are happening, or you make it wait for some time or hold the thread for some time. That time your running thread hold, it will not execute the process, it will just wait. So those kind of scenarios, your thread, like some other thread is working on it, the other thread has a hold the lock and this thread is waiting. Whenever your thread is waiting, it's not executing any part, it's just waiting. So that scenario, it will go to the blocked state. This is blocked. Let's assume that your thread is completed the task. Once the execution is completed, that is terminated when you call t1 dot stop. It is deprecated, we should not call this method. Or suspended when you call t1 dot suspend. When these methods or your execution is completed, this will go to dead state. This will go to a dead state. Clear guys, life cycle of the threads. This is very much important. We should understand when the newborn state and when is the running and runnable state, when is the blocked state, when is the dead state. Are you guys clear about this?
Ravi, can you please repeat it once again?
Yeah, sure. I will. Yeah,
Thank you.
there are different states of the thread. States means and what is the current state of the thread, whether it's running or it's waiting or it's dead or what is the states. So the life cycle represents when the thread is born and when it is started running and when it is dead. So that is the whole life of the thread will we call as a life cycle of the thread. So from newborn to terminate. So for the thread's life cycle, we have a different kind of states like a newly born, and another state is runnable. It's about to run. It is matured enough now. So it is born and it's matured enough and it's about to run. But it's not yet picked anyone. So someone has to pick and assign the work. No one is assigned the work. Still it is just it is ready to work. So someone is picked him and assigned some work. So now it is means it is started working. It means running. And someone has kept him hold. So you don't continue your work. Quickly, please wait for some time. So that is blocked state, and he completed his work or someone is said the stop, that is terminated state. And we will see here when I create a thread. Let me show you an example in the program. I'll explain that. This is newborn state. This is newborn state, and this is it's ready to run. Runnable it is, but CPU is not yet picked. Let's assume that CPU is not yet picked. As soon as CPU is picked, it is running. I can say it is running. Then once it is completed, or if here we are calling a sleep, here. It is blocked state. Not only sleep, if you call wait, or if your thread is waiting for acquiring the lock, we'll see what is the lock. I'll also explain what is the lock. If your thread is waiting for the lock, and someone is called suspend method on it, or someone called sleep method on it, right? Someone called suspend method on it. In these methods, when we call these states, your thread will be blocked. So blocked is nothing but the state moved. It's get moved from it's get moved from 1 second, guys. It's get moved from running state to runnable. It means that now again it is waiting. Runnable state, that is called blocked state. Okay, now let's assume that it's completed the execution. When it's completed the execution, we'll call it as a dead state. After the execution is completed, we'll call it as a dead state, or we can call explicitly stop. Here let's assume that I have called t1 dot stop, but it is deprecated. When I say t1 dot stop, thread is dead. Here your thread is dead state. This is the life cycle of your thread. Clear, Ramya?
Ravi,
Yeah, Rama.
so here the stop and complete both are same, or are we forced to stopping this thread actually?
See, complete is it is successful termination.
That's right. Yeah.
So stop is you're forcibly stopping it. It may complete, it may execute the process properly, or it may not. We are forcibly doing the stop.
Topic. Okay.
So it may
Okay.
cause, yeah, it may causes for some damage of the data, or it may causes something else, right? So we that is
Yeah, that means topic.
yes, that is the reason they have deprecated this method.
So like Ravi, after stop,
Hmm.
if I start again,
Yeah,
will it pick from the last state, or will it
no,
run from the starting again?
yeah, that I'm about to cover, Ram. See, if the thread
Okay.
is stopped, okay, the thread is moved to dead state, we cannot call start on it. We cannot call. It's a dead. It means that life of that thread is over. Life of the thread is over. We cannot make use of that thread. For
Okay.
making to make use of the these kind of threads, we have a concept called thread pool. Thread pool. What thread pool concept will do? We will create a set of threads, and we'll keep those. The thread is nothing but object here, right? So set of objects. We'll keep all these objects into thread pool, one place, one container. Let's assume that there is a thread pool. There is one class for it who can hold the multiple objects. Once it is the pool is created, what it will do? Always one of the thread will go from the pool and will access it, complete the execution, will come back to the pool. That is the concept of the pool. But in this case, in the normal case, if the thread is completed its life, or it's completed its execution or successful termination, we cannot revoke the same thread. We cannot do this. We cannot do this. But in thread pool, it can be possible because it has something different. APIs are there. It has some different APIs which will handle thread pool. We'll see that. Now try to execute this program. Illegal thread state exception. Where it came? Line number 70. Again we started the thread. It's a demo thread. If you see thread demo, the name of the thread is demo. Your demo thread is not even executed. This is demo thread 2 is the second thread, other thread. This is thread 2. Your thread 1 is not even executed. So it is thrown exception saying that illegal thread state exception. Once you stop the thread, we cannot start. Okay, and also if once the thread is already started, we cannot start again. See this as well. Once the thread is already started, we cannot start the same thread again. This is also thrown an exception. Here, if you observe the difference, the before thread, before when you stop and you start, it is not even executed, but here it is executed. See, demo, 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 right? Instead of saying thread 1, you can say thread 2. Your thread 1 and thread 1, thread 2. So thread 1 is executing because we already started, but again you are starting. The second start will cause an exception, but the first start will complete the execution. Clear, Rama?
Yes, Ravi.
Yeah. Rama, do you want to share something and you were asking for some, or it's by mistake you clicked?
So, and it's not me actually to organize or make the.
Ramakrishna, you're asking me to make a presenter
Oh, sorry. Maybe
by
I
mistake.
pressed something. Fine.
Okay, okay, fine.
Yes.
Now, we have seen the thread's life cycle. Now we'll see how the thread will pick and who will pick and what are the different ways the thread will be picked by CPU. And we have given some small introduction yesterday. That's called thread scheduling. Who will schedule the thread? thread scheduling. So what is the scheduling? There are two ways, two algorithms. Ideally, it will follow two algorithms. The scheduling. One is a preemptive thread. So one is a preemptive. Another one is time slice. One is the preemptive. Another one is the time slicing. What is the difference between your preemptive threads and time slicing? In the preemptive, threads or preemptive, if you are CPU using preemptive algorithm or time slicing algorithm, in the preemptive case, what it will do, it will always try to execute high priority threads. To always try to execute high priority threads. Let's assume that we have a different kind of priorities in thread. The minimum priority is 0. Sorry, the minimum priority is 1, not 0. Yesterday also we committed the same mistake. The minimum priority is 1. Max is 10. And normal priority is 5. Okay. If you give beyond this range, if you give beyond, let's say if you give 0, minimum priority is 0, or if you give 10, 11 or 100, it will throw an exception. It will throw an exception. And your main thread, the which is the thread is launched by JVM, is always use the normal priority. Your main thread's default priority is normal thread priority. Can we set the priorities? Yes, we can set the priorities. By using set priority method, we can set the max priority, min priority, or you can give the numbers as well. These are the constants. Actually, these are the constants from your parent class. This is your thread class is a parent class. So these are the constants. That is the reason we can directly make use of them. Or if you don't want to use them, you can go ahead and say 10 and say 1. It will execute. Let's try to give. I'll give here not 1. I'll give minus, or I'll give 0. I'll give. I'll give 0. What will happen? It is thrown illegal argument exception. Where? The line number 62. What is the line number 62? This is. Let's me. It's okay. 0. 0 is not allowed. Let me try with 100. Or let me try with 11. Same exception. Right? So it should be always in between 1 to 10. In between 1 to 10. Now what is the problem? Line number 70. Correct. This is the one. So it is executing. Clear, guys? Now in preemptive thread, it's always look for the higher priority thread. So most of the cases, almost it will pick the high priority threads only. So in the time slicing, it is like each and every thread will get a chance to execute. It will be allocated. It will be allocated for some time for the thread 1 and some time for thread 2 and some time for thread 3. And it will make sure, sir, your time slicing will make sure that each and every thread will get the some CPU memory for executing the threads. Okay. So we will not be worrying about these things. How we are not going to set any algorithm, or we are not going to do any explicitly. Already it will be taken care by your JVM, or your JVM will take care of this. Okay. Now let's see. There are some more methods. There are some more methods are there in threads. Those are like sleep. We have seen yesterday. Then again we'll see one more time. Wait. We have one more thing. Yield. YIELD, I think. YIELD. Yield. Notify. and there is a one more notify all. There are suspend, stop, is alive. The suspend method also is duplicated, but these are the main these are the important methods we are going to look at. And other methods, yes, those are is given by API. You guys can do a hands on, like setting the name, getting the name, and setting the priority or getting the priority, or setting the ID. You can get the ID of the thread as well. So what is the ID of this current thread, or you can check whether the thread is alive or dead. Okay, you can see them there. You can easily do a hands on by clicking dot. Very frequently we will be using setting the name, getting the name priorities, and we will be seeing is alive. Sometimes if the thread is alive, then do this operation. Or join, yeah, I missed it. This is join we are going to use. And is daemon, well, I'll explain you what is the difference between the daemon and normal threads. And we'll be seeing wait and sleep. Okay, we'll see wait and sleep method. Other methods you can know do hands on by yourself. We'll see join. These are the methods, and I'll explain it, and I'll share these programs. I have some set of programs. I'll share these programs to you. You guys please practice on them. And we're planning to start MapReduce by tomorrow, if it time permits. If you complete the threads today, we'll start the MapReduce tomorrow. Else, we'll start by Monday. Okay. Let's see what is a sleep. And sleep also putting your thread from running state to runnable state, and wait also doing the same. Then why we had two different methods? So that is a thing we need to understand, why it is two methods are for there for the same purpose. We'll see them as well. Okay, let's see a sleep demo. Here also we have used the sleep the same way. We'll see sleep, it has its own, I have written some own method for each function. We'll see the sleep demo. It's a very simple to use the sleep. So when you will go for the sleep, let's assume that you are doing uh, you are doing something like you want to make your thread for some milliseconds of wait, or some milliseconds you want to keep it wait, and when it is in waiting state you want to do some other operations. So that kind of scenarios will go with the sleep, and the sleep method has to be in the monitoring area. The sleep method may throw interrupted exception because the running thread we are stopping. So it means that we are explicitly interrupting the thread. So that is the reason always your sleep method may throw an exception. So that is the reason we'll keep the sleep method into monitoring area. Okay, what sleep method will do? The sleep method will make a current execution thread into waiting state, from the running state to runnable state. If you understand from the life cycle, from running, threads keep running, but you are explicitly saying that wait for some time. So it means that you are pulling back to the runnable state, and we will give some milliseconds of time. Once those milliseconds are over, it will automatically comes alive and will start executing. And there is a small difference when you call a sleep method. What it will do, it will hold the lock, and will go to sleep. It means that it will keep the lock, it will not hand over to anyone. It is a selfish thread. I can say it is a selfish. Even though he is going to sleep, even though he is not currently using the resource, he will not give the key to you. Others cannot access the same. So your sleep is selfish thread, or sleep method is it will hold the lock himself and it will go sleep. And there is other method called wait. It is completely opposite this. He will go to the wait state from running to runnable state, but he will give you the lock. Anyone can go ahead and access. He will return the lock. he will return the lock to the object. It means that it will be open, the door will be open, anyone can go ahead and access it. That is the only difference between this. Okay,
Ravi,
Rama.
so that case, like I will go with in the database point of view.
Mm-hmm.
So, like in the database point of view, if I use the sleep,
Okay.
so no one can access the data. But if the wait, even this the process doesn't run, it's still giving the access. But do we get the perfect right data?
Yes, we will get the right data, Rama.
Because here wait means so we are making a running thread to runnable. That means execution has not completed.
Correct.
So without completion of the task,
Yeah, I
so
understand your point. Let's assume that there is a thread is modifying some data, right? That's
yes,
what in the
like a delta.
database, it's updating data or it's modifying the data, but it has
Yes,
modified the off of the data and it went to the
wait.
sleep waiting state.
Yes, yeah,
So in this case, if other thread started accessing whatever the data it is already modified, we will get that result.
okay. But that may or may not accurate.
That may or may not accurate. But
Okay,
that is the reason on when to. First of all, the threads is not guaranteed, Rama.
okay,
The threads are not guarantee which one will execute proper and which one will execute later. Let's assume that you have 10 threads, and you never know that which thread will get the CPU time and who will execute first.
that's right. Yeah,
So
resource sharing.
yes, so what that is the reason our CPU has a preemptive threads or time slicing. So
Okay,
we never go. 1 second, please. 1 second, guys. I could wake up today. Sorry, guys. She woke up. She went. Sorry. Okay. So that is the reason we will be very careful while using the threads, and also we will make sure that whether we have to go with a sleep or whether I have to go with a wait.
okay.
And if you are using wait, right, and we have to call from other thread notify to wake up the thread. And wait has a some different kind of forms of the wait method
Yeah, yeah. That is
with.
my next question. Yeah, if it is a
Yes.
wait, so how we start again? Because the sleep, at least we are keeping some seconds, some number. It will sleep up to that time. But
Yeah.
wait also have some seconds
Yes.
time.
Yes. Wait also has the seconds time and wait also has the without seconds. I mean without time.
Okay.
So if you call like let's see thread dot wait. If I call like this,
Mm-hmm.
some other place I have to make him wait. Some other place like some from other thread I have to make him awake. How can I make awake? Like I have to do like notify. I have to call notify. So when I call notify, what he will do, this guy will make sure that whoever is sleeping in that specific thread, he will wake, he will waking up. If I go and
Okay.
say notify all, if I say notify all, how many threads are sleeping? So it doesn't matter. If any threads are sleeping, all the threads will wake up.
Sleeping or waiting?
I mean waiting.
Okay. Okay.
Okay, sleep we don't have to say explicitly wake up, and once his
Okay.
time is elapsed, and he will automatically wake up.
Okay.
Okay,
Got it.
only in case of sleep only, sorry, wait only, we have to call explicitly notify. Okay, we'll see that example as well. And also let's just me give a real time scenario. Let's assume that we have a production and consumer. In the production and consuming, let's assume the consuming is more but production is less, so we end up with the out of stock. In this case, what we will do, for each production or each consume, we will wait for we will wait we'll call the wait method. After the production is over, we'll call the notify. This is the sync actually. Why we will do this? As soon as your production is over, we'll wait for some time. The next thread cannot come, so it will wait. And when the production is over, we'll notify. It means that other can come and pick. We'll see that example. I have that example. I'll explain you that. Okay. Are you guys clear about the sleep? Let's execute this program. If you see, it's printing. It will. Yeah, it will print. I think it's taking so much of time. 10,000 milliseconds I have given. Oh, maybe that is the reason. You can make sure that whether it's running or not, this will be in the red color. It's like your background. It's running. So in the console, you can see this red color. It will make sure that it will running. And let me stop. I don't want to take 10,000 milliseconds. I'll take 1,000 milliseconds. 1,000 also more, but still we'll go with it. So it's holding for some time and sprinting and executing next line. Holding for some time and executing next line. Clear, right? Let's see. Now we'll see the join. Wait, we will see. I'll make you. Else we can go with the wait. Wait. This is again we have seen sometime before some kind of application, banking application. It's also it's kind of production consumer. We'll see this. I have a customer class. This is a customer class, and let's assume that in his account there are some dollars are there, and he's going to withdraw, and he's going to deposit. Okay, and withdraw on deposit we will do from different threads. Depositing and withdrawing will two different threads. What we are trying to do here, if you try to understand this, and I'm creating an object. It's a final object. It's a constant. Now no one cannot change this thread. And I'm creating thread. This is called anonymous class. This is called anonymous. I don't have any reference. It's not actually anonymous class. It is a orphan object. There is no reference for it. I just created a thread. I'm using. I'm accessing that object, the thread object, and once it is over, so no, it's nowhere. No one will refer that. It's anonymous object. Okay, orphan object. Let's see here. I have created thread object. Inside the thread object, I'm calling. I have a run method which has the business logic to call withdraw, and I'm calling start. It is ideally like it is representing you are creating. You are creating on thread T1 using new operator, and you will be writing your own business logic for the run method, and it is like you're calling dot start. This is the whole this is this what it is happening the same way. This is what is happening here. So when we will go for this kind of objects, I just want to access that method only once. I don't want access a later point of time. I want to access that object. In that object there is a method. I want to access that method only once. I don't want that object again. So that kind of scenarios will go with orphan objects. This if the object is get created in not only thread, you can go ahead and create with your student or employee. These kind of things will get removed while the garbage collection is executed. And the same way, I have created one thread which is executing only withdraw, and I have created one thread which is executing only deposit. Okay, then I have started both the threads. Let's assume what will happen here. One thread will start executing withdraw, and one thread will start executing deposit. And the first, if it is calling the withdraw 15,000, but he has only 10,000, and it like less balance and waiting for the deposit. It is waiting. Let's say it's just waiting. It's not even finishing the. It is not finishing the thread. It's just waiting for someone has to deposit. While it is waiting, someone is deposited. someone is deposited here and he notified, boss, I have is deposited, you can go ahead and withdraw. Let's execute this. I'm going to withdraw. I found the less balance on this, and I'm waiting for the someone has to deposit. And in between, someone is deposited, and deposit is completed. After deposit is completed, it has been withdrawn completed. Clear, guys? I mean, this after withdraw success, I'm just calling a display method to print something. Is this clear, guys? When to go for sleep and when to go for wait, I think it's make you clear. Guys, could you please respond whether you guys understood or not? I'm not able to get. Hello, Ariga. Okay,
We are good, Ravi.
okay. Yeah, that's what. Sometimes when it's on a mute, I'm not able to hear anything from you guys. I thought whether it's connected or not, it's disconnected or something. Okay. Then next, go for join. When we will go for the join, let's assume that there are few threads are running. When I call join on one thread, it will make sure that others wait and he will complete first. Let's see here. I have a run method. It's a very simple method. I have a run, and which is just printing the name and I value, and it has a couple of threads, and thread 1 and thread 2, and I have started them. Okay, after that I'm just doing thread dot join. Second thread, I'm doing thread 2 dot join. What this thread 2 dot join will do, just execute. So main thread is started, and thread 1 started printing the values, and it's to hold the thread, it's a hold at the main thread, and this thread is finished. Let me make you very much clear. I have one more. I can show you. I think I can write one more program which will make you very simple. Join demo. Which extends thread. Because I don't have anything to extend, I'll just write a run method. So it's very simple logic, as similar as the printing some numbers. Here I'm doing from 0 to 10. I'm printing and making my thread to wait for some seconds, and I'm printing the name of the thread to make sure that which thread is printing. And in main method, I can print this at the end. I don't want to print here. If I print it here, you may get confused. Let's let it wait and just print again. Go to main. We just create thread for them. Join thread demo. New join demo. And id dot. It's supposed to be JD. Okay, it become ID. Let's create two more threads. I need to join, right? Two Two threads are enough. I don't need three threads. Now start. After starting it, I'm making him join. Join. It may throw interrupt exception. Cache block. Interrupted exception. E.print stack test. We're not going to do anything here. And after that, we'll just start execute id2.start. And save it. Start run. The first thread only started executing. The second thread is not yet started. Thread 1 is start executing later. And also, I'll make you very much clear. There will be one more thread. It's called main thread, right? There will be one more thread will be executing. The default, the default thread which is launched by our JVM. Let's see. Thread dot current thread dot get name. This is main thread. It will print the main thread name. After this, let's assume that I have some more print statements. Main 2. Before, without join I'll show you. Then only we can make the difference. Without join we see. What has happened? Main started and main 2, main 3 is printed. The last lines are printed and the child threads are running now. 0, 1, 0, 1, 0, 1. Some sequence. Sometime it will come the first it will execute the thread 1 and again it's execute thread 2. Thread 0 is means your first thread ID. ID 2 is the second thread. So it is executed. Now just go with Control Z. Yeah, joins. And let me show you one more time the result. If you see here, your main thread is executed, it's completed its execution. That means it executed this and it launched the thread 1, it launched the thread 2 and it's executed this statement and this executed this statement. So your main thread's job is done. Now the child threads are taken over and child thread 0 is executing this thread 1, again 0, 0, 1, 0, 1, 0, 1, 0, 1. Sometimes 1, 1 only came twice immediately because we cannot guarantee that which one will execute first and which one will execute later. Right? Now let's see, after joining a thread 1, what is happening? Your main thread is not completed. It's a main thread just came and is waiting. Your main thread is not completed. Even your thread 2 is not yet started. Once your thread 1 is completed, then your main thread is completed. So when you call a join on a specific thread, it will make sure that other thread will wait for him to complete. I hope this example clears you. It makes sense about the joins. When you call a join, this what it will do, it will make sure that others will wait for him to complete. If I call him on t1 dot join, your t1 will finish first, then others has to wait for him. So this is about joins. And yield, okay, we have seen this, and we have seen this, notify all. Now yield method. Let's
Ravi, here I have a question.
go ahead, Rama.
Let's consider I have 10 threads.
Okay,
Out of 10 threads, like if I use join for 4,
okay,
so within the 4, again, which will take the first priority?
okay, we'll see that, Rama. So whichever the thread you'll call first, right? That thread only. Let's assume
Oh, okay, okay. So that means, okay, now I got it.
3 4. Okay, now I have called on 3 dot join,
Okay,
not td, it is id actually. Dot join.
okay.
Now,
Like they will, the precedence will be the calling order, right?
correct.
Okay, okay.
Let's
I'm
assume
good with
5.
it.
Yeah, we'll just try it, Rama. I'll
Yeah, sure. Yeah, sure.
and let me give names for these guys. We can give names from here. It's giving error. I'll tell you why it is giving error. We can give the names from our constructor itself. Thread 4, thread 5. Your join class doesn't have the constructor, so we have to call on. We have to create a constructor here. This constructor is expecting a name.
Okay.
We have to call soup. We have to pass this name to super because our super name thread is expecting name. So we are going to give the name for super thread only, not for the child.
Great.
So now it is done. Now thread 1 will execute. Thread 2, I mean thread 3, thread 4. We'll see the sequence. And here id 5 dot start. Main is holded and thread 1 is starting. Thread 1 means our we have given the name as thread 1.
Hmm.
And thread 2 start. Okay.
Why
Thread
thread 5
2.
becomes clear?
Why it is thread 3?
2 5 actually, 2 5
No,
started parallelly.
thread 3 and thread 5 is not, the thread 3, thread 4 is not even executed. No, we didn't call
Exactly.
them. No, we didn't start them actually.
Exactly. Yeah.
We did mistake. We didn't start them.
Okay.
id dot start.
33.
id 4 dot start.
ID 4. Okay.
Thread 1, thread 3, thread 4. Thread 1, yeah, in between I think it is taking random again. So it is not coming as a sequence inside the join. It's not even the precedence. And which will come first one. Thread 1 is thread 1, thread 3. Let it finish. Thread 1, thread 3, 4. Again 1, 4, 3. There is no sequence here. So it's randomly executing inside the try.
Then in that case, Ravi, let's consider like I have a dependency job.
Okay.
Let's consider I have 4 tasks.
Mm-hmm.
So out of 4 tasks, actually the task 4 will be getting the data from 1 to 3.
Okay.
But again, 2 will be dependent on the 3. Like it's, I can say the 3 threads are interdependent on each other, but one will not be starting until unless the other thread execution has completed.
Yeah, it's kind of your previous example, withdraw and deposit.
Okay, okay,
So there we have to make sure that we use the wait and notify.
okay.
Clear, Rama? Even in the real time, we will not be calling like this. Four threads will keep it to join or
But
make. Yeah.
let us consider, Ravi, like the real time itself,
Hmm.
like in the database point of view.
Okay.
If there are certain tables,
Okay.
so the other table execution
Hmm.
will start after completion of the other's execution. Like in the order, if I have a 1, 2, 3, 4 load jobs,
Okay.
load job 1, otherwise load job 3 will start only after completion of the load job 1.
Okay. That we can that we can do with the wait and notify, Rama, or we can do with
Okay.
synchronization. One thread will come
Yes,
first. That
with
we'll do with that.
synchronization. Okay.
So that scenarios also will not create threads like this. There will use the thread pool concept. Even because we'll
Okay.
be having the connection pool. Because multiple guys will be accessing the connections. Multiple guys need the connections. So for the connection
Okay.
also we'll maintain the connection pool, and for threads also we'll use the thread pool. And from the
Okay.
thread pool, by default we'll specify some number of threads, 100 threads. And whoever comes, I mean whoever pick the first thread, and that thread will go and execute the take the connection object from the connection pool, and it will start executing.
Okay.
So these are simple examples though to understand the concept.
Yeah. Okay. Thank you.
Next one is yield. Okay. So yield will, if you actually this yield is a little confused one. So it's not guarantee that will execute, but I'll explain what is the yield. The yield method will make sure that if one thread is running, and if you call on that thread, if you say yield, what it will try to do, it will allow the next high priority thread will execute. It will allow to a next high priority thread will execute. Let's see here. Let's assume that you have some three threads, and one thread has a high priority, and one thread is already got the CPU time, it's executing. On top of that, if you call yield, it will hold him, and who has the next high priority thread will start executing. We'll see an example for this. Here where we are setting, let me take a proper example. This is a little confused Rama, because we may not able to prove this yield one with example. So I have a couple of examples for that. Let me look at which one will suit and give you a proper example. Let me see this. We're displaying here, and we're calling yield. Okay, and run. So product and consumer. Producer will do this, and consumer will do this. Let's try to understand this example. First, we'll try with the without yield, and we'll see the difference. We have two different threads. One is the producer producing the thread, and other one is consuming the thread. Okay, and we are calling both. And producer came, and it's not even, we cannot predict, it may come differently. If I execute it one more time, it may come differently. Again, the producer come, consumer come, producer, consumer, producer, consumer. It came, if I execute one more time, it came come as a different order. So we never predict the Now we never predict the which thread will get the first and which will execute. And let me try with the priorities. Still I didn't use the yield. Consumer, producer, producer, consumer. Is it always the same? No, this is also not predicting because even it's not picking the high priority. Now let's call yields. Producer, consumer, producer, consumer, producer, consumer, producer, consumer. If I execute one more time, will it be the same order? Yes. So yield also the same what we have done in the sleep or wait, right? The same kind of it's moving a current running thread to runnable state, and next it is allowing to next thread to execute. Actually, let's see what yield method is, how it has been defined. Oh, it is static method. Implementation. No, it is a static abstract method, but someone has to provide the logic. This one. No. Okay. So what yield method will do? The current whatever the current thread is running. If I call yield on that thread, what it will try to do? It will try to make the thread in from running state to runnable state, and it will allow the next high priority thread to execute. Next high priority thread to execute. Let's see here. I'll remove the priority. Will it execute the same way or not? See, now the order is different. Before is always producer consumer producer consumer. If with the priorities, if you see here with the priorities, if I execute, so producer consumer, it's a sequence, right? First producer will getting called and then your consumer is getting called. Now without priorities, yield is still used. I don't have the priority. The default priority is normal priority. Both has the same priority now. It means that both has the same priority. When I execute this, producer consumer came for some time, but if you see the last, producer only came twice and no consumer came later. So it's explaining here. It's when I called yield method, it is a current running thread will hold, and the next high priority thread is getting executed. Clear, guys? If you guys are not clear, I'll come up with a good example to explain you better. And most of the cases will not use this in real time. We'll mainly use wait, sleep, maximum wait and sleep only. Join also will not use because these guys will interrupt. We never know whether they will execute or not. Clear? Or if you guys have still doubts, and now I'll come up with a better example for this to explain. Go ahead, Rama. I think you want to talk something.
Yeah, Ravi, can you explain with the example, please? If you have an example, would you please walk through that?
Okay. Let me. This is one example. This example is producer consumer, and let me check other example. What I'm trying to do here, if it is I equal to 2, I'm just yielding on current thread. Our list. Rama, can I explain this yield tomorrow with a better example? Let me
Yeah,
try
sure,
to.
Ravi.
I'll go
Yeah,
through something. I'll do some research on this. I'll understand. I'll make it explain this.
yeah, sure. Yeah,
Okay. So yeah, that's it for today. So if you guys have any doubts apart from this yield, uh, please go ahead and ask me, or I mean whoever has the doubts, they can stay back and others can leave for the day.
thank you, Ravi.
Yeah. Thank you, Rama.
Catch you tomorrow.
Yeah. Thank you.
Thank you, Ravi. See you in tomorrow's session.
Okay. Yeah. Thank you, Bharat.
Bye.
Bye. Hello.
Thank you. Are you
Yeah.
able to hear?
Yes. Yes. I'm able to hear you. Thank you, Sri.
Yeah.
Yeah.
Ravi, one thing.
Go ahead,
So
Ram.
Saturday, you are not planning for any class for this week, right?
No, Saturday, Sunday. I'm not planning for this. Monday
Okay,
will
okay.
Monday will
So
start. Monday will start the map reduce.
it's map reduce. Fine,
Map
fine.
reduce. Yes.
Okay, okay.
And I'm also
Okay,
planning
Ravi.
for to some assignments in the HDFS and Java. I'll prepare some questions and
Okay.
I'll upload into the drive.
Yeah.
So you guys can go through. I already have uploaded some of the interview questions. So
Yeah. Hadoop QA and yeah,
yes.
there's that,
So
that thing you uploaded, right?
yes, yes.
Ah,
I think those itself will make no will make you some. It'll make you. It'll prepare you for interviews. It has a good
yes,
questions and
yes. Okay.
explanations as well.
Yeah, yeah. Sure. And also yesterday you asked us like, are we comfortable writing a program and all?
Yes,
So in your
exactly.
assignment, you can give us one scenario. Prepare this kind of outcome. Prepare program for this kind of output. Like we will prepare. I mean,
Sure.
for our better practice.
Okay, I'll do that. I'll upload that questionnaire also in our drive.
Yeah, questionnaire. Correct. Yeah. If you give any scenario, accordingly we'll write program and execute and yeah,
Fine.
get the output.
Sure, Bharat. I'll do that.
Okay. Thanks, Ravi. Bye.
Thank you.